Blue skies whisper secrets of endless possibilities. Hi everyone. In the last video, we went through principle of counting. In this video, we will go through permutations when the objects are distinct. We will also look at derivation of permutations formulae.
In the last video, we spoke about permutations a little, right? We discussed that permutations is nothing but arrangement of objects, right? Now, we took this example of mobile lock or mobile pin. If the mobile pin number is 6723, then you have to enter the pin number in the same sequence, right? The same sequence you have to enter the pin number, only then you can unlock your mobile, right? So which means sequence is very important. Sequence is important, right? I cannot enter a different sequence. Say I can't enter 6237 or 6732, right? I cannot do this. I have to enter the digits in this particular sequence. Now, permutations is nothing but arrangement of objects in a sequence. Sequence matters. In permutations, sequence matters. You could have different arrangements, right? We using multiplication principle, we can find different arrangements, correct? But each arrangement, in each arrangement, the sequence matters. In each arrangement, sequence matters. For example, we'll take another example. Say you have a fruit bowl, right? In fruit bowl, you are having different types of fruits. Now, does it matter in the fruit bowl in which order or in which sequence you add the fruits? Does it matter? It does not matter. It does not matter whether you add apples first or grapes first or oranges first, right? It does not matter. The order does not matter. You can add these fruits in any order in a fruit bowl, right? So this is not permutation. This is not permutation. This is combination, right? There are two concepts in permutations and combinations. One is permutation and one is combination. Now, permutation is a arrangement where sequence matters. Combination, sequence does not matter. Sequence does not matter, right? Now, let's take another example. Say you're forming a team, right? Say you're forming a cricket team, right? Now you'll be choosing players. You'll be choosing players, right? Now, does it matter how you choose the players? I mean, in what order? Does it matter whether you choose your wicket keeper first, batsmen, bowlers, right? Does it matter in which sequence you choose? It does not matter. You can choose in any sequence. Maybe you can choose all the batsmen first, bowler first, wicket keeper first, and then form a team. The order or sequence does not matter in combinations. But in permutations, it matters, right? Simple example is mobile pin. So another example is forming words, right? Forming words, right? Such as, for example, rose, right? Now, if I change the sequence of these letters, the meaning will change, right? Meaning will change if I change the sequence of letters. So instead of rose, if I write soar, the meaning changes, correct? So similarly, when I am forming numbers, right? Say I have 3 2 1 2, right? And then I have 2 1 2 3. Here, does it, the sequence matters. The number changes here. Here it is 3212. Here it is 200123. So by shuffling or mixing up the numbers, mixing up the digits, the meaning changes. The meaning changes, right? Therefore, this is permutations. So in permutations, whether you're forming words or forming numbers or a mobile pin, whatever, right? The sequence matters, right? Arrangement matters. Sequence matters, arrangement matters, right? Or order matters. Anything. Order matters. Whereas in combinations, it does not matter, right? Example, forming a team or a fruit bowl. So, coming to the definition of permutations, right? Permutations is nothing but arrangement of R objects taken from N objects. So, you have N objects, you are taking R objects and making an arrangement. Simple example, right? We saw in the last video. If you want to form a 3-digit number given, say 6 digits, you have been given 6 digits 1, 2, 3, 4, 5, 6, and you want to form a 3-digit number, right? So you can say this is N objects and R objects, right? So you are forming R objects from N objects. You are forming R objects from N objects. So arranging in this way is called as permutations, right? So example, you are forming 3-digit number from 6 digits. Now, how do you represent this, right? We need to denote this, right? How do we denote this? So what is the notation for permutation? How do you denote that it is permutation, right? So we will have to write NPR. So N is N objects, total objects. R, and you're choosing or you're selecting R objects, right? From N. N is a bigger number, right? N is a bigger number, right? And from this N objects, you're choosing R objects. Now, in this example, from 6 digits, I need to form 3-digit number. So how will I write? It should be NPR. So what is N? N is 6 digits, right? N is equal to 6 digits. What is R? I need to form 3-digit number. So R is equal to 3. We'll write it as 6P3. You're choosing 3 digits from 6 digits, right? So we will put it as 6P3. So the notation is 6P3. Here, when we are forming 3-digit number, from 6 digits, first what we were doing, we were seeing how many ways we can choose the first digit. How many ways? 6 digits. Now this is all a no repetition case. Permutation, we are dealing with no repetition. Distinct objects, right? So every object should be different, right? Every object should be different. There should not be any repetition, right? We are dealing with that particular topic. So now, first digit we will take 6. There are 6 possibilities. So 6 ways. Second digit, no repetition. So 1 you have already chosen. So you are left with 5 digits. Now we have to choose the third digit. So how many digits are pending? Out of 6, 2 are chosen. So 4. We have 4 possibilities or 4 remaining digits. So finally we multiply and say 6 into 5 into 4, which is
120 ways.
So, like I said, this is a topic where we are discussing about permutations when there is no repetition or when the objects are different, where every object or every digit is different, right? So now we will try to get this answer, right? The 6 into 5 into 4 using permutations, right? Using formula for permutations, right? So what is it? We have to choose 6, we have to choose 3 digits from 6 digits. So it's 6p3. And what is the formula? Formula for permutation is n factorial by n minus r factorial. So this is the formula. Here, now in 6p3, n is equal to 6, r is equal to 3. Right? N is equal to 6, r is equal to 3. So we will substitute. Right? Instead of n, we put 6 factorial. Instead of n, we put 6, and instead of r, we put 3. So 6 minus 3 factorial. So we'll get 6 factorial by 6 minus 3 is 3 factorial. Now we will expand, right? We know what is factorial. We have to keep on reducing the number until we reach 1. So it will be 6. We start with 6 into 5 into 4 into 3 into 2 into 1. We stop. We have reached 1, so we stop. Now similarly, what is 3 factorial? 3 into 2 into 1. Now let's simplify. Let's cancel it out. 3 and 2 will get cancelled. So we are left with 6 into 5 into 4, which is equal to 120 ways. Right? We got the same number here. Here we got the same thing. Right? So now we have solved it using permutations formula. So now let's solve few problems to understand factorial related problems. Evaluate 8 factorial, which means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So we stop it here since we've reached 1. Now we can calculate this entire thing. We will get 40,320 as an answer when you calculate this. Next one is 4 factorial minus 3 factorial. 4 factorial minus 3 factorial. So first let's expand 4 factorial. What is 4 factorial? Start with 4. Keep on reducing. 3 into 2 into 1. Stop it here. Minus 3 factorial. 3 into 2 into 1. Now you solve this. So 4th is a 12. 24 minus 6. 24 minus 6 is 18. Now similarly, we'll go to next problem. Is 3 factorial plus 4 factorial equal to 7 factorial? No. 3 factorial plus 4 factorial is equal to 7 factorial? No, because let's verify. Right? What is 3 factorial? It is 3 into 2 into 1. Put brackets. Plus, what is 4 factorial? 4 into 3 into 2 into 1. Put brackets. So now you multiply. 3 2s are 6. 12 2s are 24. 24 plus 6 is 30. Okay. Now we'll expand 7 factorial also. 7 factorial is start with 7 into 6 into 5 into 4 into 3 into 2 into 1. So when I calculate, I'll get 50, 40. Here we got 30 and here we got 50, 40. Are they same? No. Therefore, 3 factorial plus 4 factorial is not equal to 7 factorial. Now let's look at another example. Compute this expression. Right? 8 factorial is given. So again, what is 8 factorial? 8 into 7 into 6 into 5 into 4 into 3, 2 into 1. Now 6 factorial. 6 into 5 into 4 into 3 into 2 into 1. Into 2 factorial. 2 into 1. Right? So you'll cancel 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. And you have 2 here. 2 ones, 2 4s are. 4 7s are 28. So 28 is the answer. Now we'll solve this. Find x. Right? So what we'll do here is, like a normal simplification, we'll find LCM here. Right? Because you have 2 different denominators. So when I find LCM, it will be 6 factorial and 7 factorial in the denominator. I'm multiplying both the denominators. And this will go how many times? Right? Here you have 6 factorial. How many times will it go to get this particular LCM? 7 factorial. Here you have 7 factorial. If you have to get this as the denominator or this as the LCM, how many times you have to multiply? 6 factorial. Right? Right? Basically, here you have 6 factorial. You have to get this as the LCM. So you multiply this with 7 factorial. Here you have 7 factorial. If you have to get this as the LCM, here you have to multiply with 6 factorial. But you will not multiply the denominator. You will multiply the numerator. That's all. So 7 factorial into 1 is 7 factorial. 6 factorial into 1 is 6 factorial. X by 8 factorial. Now I'll expand. Right? Now I'll expand. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 6 into 5 into 4 into 3 into 2 into 1 by, you have to multiply this. Let's leave it like this for now. We'll first solve this. So to make it easier, what I will do is I will take common factor. So now this is an addition, right? There is plus sign here. What is common here? 6 into 5 into 4 into 3 into 2 into 1. This is common here. So I'll take this common. I will take 6 into 5 into 4 into 3 into 2 into 1 as common. Here what I'm left with? 7. Here there is nothing, right? So it will be 1. This entire thing has been taken as common. So I'll be left with 1 divided by 6 factorial, 7 factorial into x by 8 factorial. Now this 7 plus 1 is 8. So I'll get 8. 8 into, now what is this? This is nothing but 6 factorial, right? 6 into 5 into 4 into 3 into 2 into 1 is nothing but 6 factorial. Let me write it as 6 factorial by 6 factorial, 7 factorial to x by 8 factorial. The reason I put factorial here is it becomes easy for me to cancel. I can cancel 6 factorial here and 6 factorial here, right? See, we could have calculated using calculator and then added it up. But this is more simpler because it will get cancelled. You can avoid the calculation steps. So now I'll get 8 by 7 factorial into is equal to x by 8 factorial. So now I need to find the value of x. So it will be x is equal to, let me shift it here. So from it is there in the denominator. When I shift, it will become multiplication in the numerator. So it will be 8 factorial into 8 by 7 factorial. Right? Now what I can do is, see, there is one shortcut. When you write 8 factorial, you can write it as like this, 8 into 7 factorial. I can write it like this. What is 8 factorial? It is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Now you just take this portion. What is this portion? It is 7 factorial, right? This portion is 7 factorial. So you can write 8 into 7 factorial. You can write this, right? So I should write 8 into 7 factorial. I can write like this, into 8 by 7 factorial. Why I wrote it this way? So that I can cancel the 7 factorial and 7 factorial. I'm trying to simplify the calculations. So I cancel 7 factorial and 7 factorial. I got 8 into 8, 64. So what is x? We found the value of x. X is equal to 64. Right? And remember one thing, 1 factorial is always 1 only. Right? 1 factorial is 1. And 0 factorial is always 1. 0 factorial is 1 and 1 factorial also 1. Remember this. Right? 0 factorial is equal to 1. 1 factorial is equal to 1. Now we'll solve fifth problem. Evaluate this particular expression. Basically permutation formula. When n is equal to 6, r is equal to 2. And n is equal to 9, r is equal to 5. Let's take the first one. N is equal to 6, r is equal to 2. So substitute. N is 6 factorial. N is 6 minus r is 2. I'll just substitute. We'll get 6 factorial by 4 factorial. Now we'll use a shortcut, right? Instead of expanding, we'll write it as 6 into 5 into 4 factorial. Right? And then I have 4 factorial. Why am I doing this? So that I can cancel the denominator. Right? I can cancel 4 factorial here and 4 factorial here. See, it's the same thing, right? 6 into 5 into 4 into 3 into 2 into 1. This is 6 factorial. And 4 factorial is 4 into 3 into 2 into 1. Now this entire 4 portion, 4, 3 to 1 is getting cancelled. You're left with 6 into 5. So I'm putting it as a shortcut. 6 into 5 into 4 factorial. Right? This entire portion is 4 factorial, correct? 4 into 3 into 2 into 1 is 4 factorial. So now 4 factorial and 4 factorial get cancelled. I'll be left with 30. So answer is 30 here. Now we look at the second problem. When n is equal to 9 and r is equal to 5. So we'll substitute. So 9 factorial by 9 minus 5 factorial. So now what I'll do, this will be n factorial, 9 factorial by 9 minus 5 is 4 factorial. Now what I can do, I'll write this as 9 into 8 into 7 into 6 into 5 into 4 factorial because I have 4 factorial in the denominator. Right? Now, so that it will help me in my calculations. So I'll cancel 4 factorial directly. Now I have to calculate this. So when I calculate, I'll get 15,120 as the answer. Now one thing, what is the permutations formula? It is nothing but NPR, which is nothing but n factorial by n minus r factorial. Right? Now, we can also say permutation formula is nothing but n into n minus 1 into n minus 2 into n minus 3 till n minus r plus 1. We can say this. Right? How? Now, you remember the 6p3 problem? Choosing 3 digits from 6 digits. We said it is 6 factorial by 6 minus 3 factorial, which is nothing but 6 factorial by 3 factorial, which is nothing but 6 into 5 into 4 into, I can write it as 3 factorial by 3 factorial, right? You can cancel this and I'll be left with 6 into 5 into 4, correct? This is what I'll get finally, right? Now, the same thing, I can write it in this form. What is 6 into 5 into 4? What is 6n, right? What is r here? 3. What is 4 here? If you look at 4, 4 is nothing but r plus 1. 4 is r plus 1, correct? And n is 6, right? So now I'll use this method. So 6 is n into, this is n minus 1, correct? And what is this? This is nothing but n minus, what is 4? 4 is r plus 1. N is 6, n minus 1 is 5. And now if I subtract this, 6 minus r is 3, 3 plus 1, right? So it will become 7 minus 3, which is 4. So we got the same thing. So this is an alternate way of writing it. Alternate way, right? So basically, now let's take, say, another example. So we'll take it as, say, 10p6. We'll take this example, 10p6. Here n is equal to 10, r is equal to 6. Now I can write this actually as, if I use NPR formula, permutation formula, I'll write it as 10 factorial by 10 minus 6 factorial, which is nothing but 10 factorial by 4 factorial. Now I'll expand this. I can write this as 8 into 7 into 6 into 5 into 4. I'll stop it at 4. Put factorial here so that I can cancel it. Right? I can cancel this. Now I'll get this entire expansion. Right? Now I can write this in this alternate form. N into n minus 1 into n minus 2 into n minus 3. You should keep on reducing this until n minus r plus 1. Now we'll verify. Right? So now here n is equal to 10, r is equal to 6. So let's use this expansion. N is 10. 10 minus 1, 10 minus 2, 10 minus 3. I should continue until 10 minus r is 6 plus 1. This will be 10 into 9 into 8 into 7. I should continue until 4 plus 1, 5. I should continue until 5, which means it should be 10 into 9 into 8 into 7 into 6 into 5. Here I stop it. Isn't this and this same? Here also you have 10 into 9 into 8 into 7 into 6 into 5. Isn't both same? So basically you're telling NPR, which is this formula, right, is same as n into n minus 1 into n minus 2. Keep on writing this, reducing this until n minus r plus 1. Both of these are same, right? Now we can prove this. See, we already proved that using an example. Using example, we proved it. Now we will derive it in a generic form. Generically, let's derive it. Basically, we need to prove that this is same as this expression. Both of these is same, right? Now to prove this, what we will do, we'll multiply and divide this entire expression. We'll start with this expression, right? We'll start with this expression. We'll multiply and divide by this one, n minus r into n minus r minus 1 into till 3 to 1. We'll multiply and divide, right? Just remember, you have to multiply and divide by n minus r into n minus r minus 1 till 3 into 2 into 1, right? So then once you do that, what will happen here? This entire expression that you're seeing is nothing but n factorial. Because what is n factorial? You'll start from n and you'll go till 1. You'll start from n and go till 1. Here, right? So here you have n minus r plus 1. Then again you keep on reducing 1 here. Right? If I keep on reducing 1, I'll reach this particular expression. This is nothing but n factorial. Right? See here, you have n minus r plus 1. In the next step, I'll reduce 1. Right? Every time I have to reduce 1. Now I'll reduce 1 here. What will happen? Plus 1 and minus 1 will get cancelled. I'll be left with n minus r. Now again I have to reduce 1 here. So what will happen? It will become n minus r minus 1. So this one I'll get. Right? So this will go till I reach 1. Now what is this? What is this denominator? You're starting with n minus r. It's going till 1. Here 1 is getting reduced. N minus r. From n minus r you're reducing 1. So if you continue this, it will go till 3, 2, 1. So what is this? This is nothing but n minus r factorial. This is nothing but n minus r factorial. You're starting from n minus r and you keep reducing it by 1 till you reach 1. So therefore NPR becomes n factorial by n minus r factorial. Now let's try this out. Right? Let's work it out. So we'll start with NPR is equal to n into n minus 1 into n minus 2 till n minus r plus 1. Now this is what you have to prove. So I'll multiply and divide. I'll multiply and divide by n minus r. Then I'll reduce 1 from this, n minus r minus 1. It will go on till 3 into 2 into 1. So what will happen? NPR is equal to n into n minus 1 into n minus 2 till n minus r plus 1. Now I'll multiply this whole thing with n minus r minus 1 goes on till 3 into 2 into 1. I'll divide by the same thing. So n minus r into n minus r minus 1 goes on till 3 into 2 into 1. Now if I notice this, I'm reducing 1 in each term. So n minus 1. From n minus 1, if I reduce 1, it will become n minus 2. Here it comes to n minus r plus 1, right? And when I reduce 1 from this, right? When I reduce, so it will be like this, n minus r plus 1. Now I have to minus 1, right? I have to reduce 1. So 1 and minus 1 will get cancelled. I'll be left with n minus r. Now again from n minus r, I reduce 1. So what will happen? It will be n minus r minus 1. Basically this term. Now if I continue to do this, I will reach 3, 2, 1. So what is this entire thing? You're starting from n and you're reducing till 1. What is it? It's n factorial. This entire thing is nothing but n factorial. So the numerator is n factorial. Now, similarly, here you're starting with n minus r. From n minus r, you're reducing 1 here. So you keep on continuing until you reach 1. So what is this? This is n minus r factorial. That's all. So now if you notice, you started with this particular expression, right? You started with this expression, right? And you landed up in this expression, which means both are same, which means the permutation formula can be written as n factorial by n minus r factorial, or you can write in this form. So this is nothing but proof for NPR. This is the proof. This is the derivation, right? So this is the derivation for permutation formula NPR. And remember one thing, you have to write 0 less than r less than or equal to n. This r should be equal to or less than n. We know, right? N is a big number, r is a small number. So r should be less than or equal to n. And of course, it cannot be 0, right? You cannot have 0 here. Basically, you cannot have negative r. It should be only positive number. So put this where 0 less than r less than or equal to n. So this entire thing is nothing but proof for permutation formula or derivation for permutation formula. Derivation for NPR. This entire permutation formula is for objects which are not, this is for objects which are distinct. Distinct means different. Distinct means different. So this formula works only when the objects are distinct or different, right? So when you look at the digits 1, 2, 3, 4, 5, 6, and we were forming 3-digit number, right? If you forming 3-digit number, if you notice this entire list, it's different numbers. Each of the digits are different. There is no repetition here. No repetition here. That is when this formula will work. Now what will happen when there is repetition? Right? So when there is repetition, we call that permutation when all objects are not distinct. That means there could be repetition, right? There is another method to solve when objects are not distinct. We will cover this in the next video.
So we will end this video here. If you have liked this video, do press a like and share it. Thanks for watching.